everyone. Today we will discuss about another circuit. We are applying the plus or minus 10 volt at the input, and we are going to measure the output voltage at the VL. Here we are considering the ideal diode D1, so that when the D1 is in forward bias condition, it will be act as a short circuit, and in the reverse bias condition it act as a open circuit. Here for the time period T, from the 0 to T by 2, the input voltage Vs as a 10 volt, and from the T by 2 to T, input voltage is a minus 10 volt. Let us apply the 10 volt at the Vs. So if we apply the 10 volt at the Vs, this diode acts as a forward bias condition, and we will verify whether this diode is conducting or not. To verify this, we need to disconnect this diode D1, and we need to measure the voltage difference between A and B. If the voltage difference between A and B is more than 0 volt, we can conclude that the diode is conducting. For that, we need to check the Thevenin's resistance. If we apply the parallel rule, we will get the 100 ohm resistor at this location due to this voltage divider rule. Okay, so 100 due to here 100 ohm resistor, and here also we will get 100 ohm resistor, so that we can conclude we are getting the 5 volt here. So now it is 5 volt is more than 0 volt, so that we can conclude this diode is conducting. Initially we have told when the diode is forward bias condition, it acts as a short circuit. Once it acts as a short circuit, we will get the same voltage which we have applied at the source. So we can conclude that we are getting 10 volt here. At the same time, like minus 10 volt we are going to apply. Once we apply the minus 10 volt, this diode D1 act as a reverse bias, means it will be in the off condition. Once it off, R1 and R2 act as a parallel resistor. If we apply the parallel resistor rule, R1 into R2 divided by R1 plus R2. So R1 is 200 and R2 is also 200. Totally we will get 100 ohm resistor. Once we apply the minus 10 volt at the source, we are going to measure the output at the VL present between the R1 and R3. So we have to measure the voltage at node A. Okay, as per the Thevenin's voltage rule, Vs into R2, where we have to measure the output, divided by R1 plus R2. So input voltage is 10 volt, and we are going to measure across the resistor R2. The value of resistor R2 is 100 ohm resistor, and divided by R1 plus R2. So that finally we are getting minus 5 volt. Okay. So we can conclude this circuit like, if we apply the plus or minus 10 volt at the input, we are getting positive 10. In the positive cycle we are getting plus 10 volt, and the negative cycle we are getting minus 10 volt. Let us simulate this circuit. So here I am going to apply the pulse. The initial voltage is minus 10 volt, and the higher voltage is plus 10 volt. Here 0.01 millisecond time period, 0.01 millisecond time period, and here T1 is 1 millisecond, and time T period is 2 millisecond. Okay, let us apply. And let's run the circuit. Okay, see, 1 volt, it is minus 10 volt. See, initially it is start from when it is negative, input is negative. When the input is negative, it start from output voltage is minus 5 volt, and it goes on increasing. When it is positive, when it come to the positive side, it will go up to 10 volt, and similarly again it is when it is come to the negative, it will go up to the minus 5 volt, and goes on continuing like this. Hope you understand this circuit. Thank you for the watching.